Before cell phones became popular, there was a tendency to think about telephones as relatively static. Most phones didn't change locations frequently, and the circuit-based nature of traditional telephony kept a tight coupling between a phone and the number dialed to reach it. In the VoIP world, where the number you dial to ring a phone doesn't necessarily relate to the physical location of the phone or what network it is on, the direct mapping doesn't exist. Because of this, VoIP devices must know the network address of any other devices they wish to connect to. It's possible to explicitly configure VoIP phones or switches with the exact IP address or host name of each peer it connects to, but as we'll see in this module, a mechanism called registration provides a way for a VoIP endpoint to dynamically notify its peers of its network location. SIP, EECS, and several other VoIP protocols allow an endpoint to send a registration request to Asterisk. This registration request should always include a username and the network address at which the device can be reached. It may also include other authentication credentials or request the duration of the registration. If Asterisk confirms the registration, the network address for the VoIP user is remembered and associated with the device listed in the configuration for the appropriate channel driver. Then, if Asterisk is asked to dial that device while the registration remains valid, it knows where to send the call to find the phone. Asterisk stores the registration data in a small Berkeley database so that registration records persist even if Asterisk is restarted. It's possible to tell Asterisk exactly how to reach a VoIP device without relying on registrations, but this reduces flexibility and can lead to more maintenance effort in the long run. It's common even on static IP networks to rely on VoIP registration to provide Asterisk with the addresses of VoIP phones on the network. Having a layer of abstraction between the IP network and VoIP application makes it easier to change one out without having to change the other. And, of course, VoIP registration is really helpful on networks where IP addresses are dynamically assigned or when the VoIP device itself may connect from more than one address. Let's look at how to set up VoIP registrations. There's usually very little setup required on a VoIP phone because they'll almost always be sending calls to just one or a few servers. Registration can only work in one direction at a time because it's a tool to let one device announce its location to the other. For that to work, the device wanting to register must know where to send the registration request. This works out well in a VoIP environment because we typically have to tell a phone what server to send calls to anyway. It's easy to have a phone send calls and registration requests to the same place. If you've already set up a VoIP phone to send calls to Asterisk, you might not have to do anything else on the phone. It may send registration requests automatically, or you may be able to configure whether or not it sends registrations. It's not much more complicated to configure Asterisk to accept registration requests. For each device that will register to Asterisk, simply add a configuration line saying host equals dynamic in the configuration section for that device in sip.conf or eeks.conf. You may have already done this without realizing what it meant. The host line tells Asterisk where to send calls for the device. If you set it to a DNS name or IP address, no registration is necessary, and in fact, Asterisk will reject any registration requests it receives for the device. You can still use IP-based access control for VoIP devices registering to Asterisk. The permit and deny configuration parameters for a device let you specify white or black lists of IP addresses, so you can still have fine-grained control over which networks and even specific IP addresses a device can register from. It's also possible to set the duration of valid registrations, though it's common to use the default values. If Asterisk is asked to dial a VoIP device that is not currently registered but is configured for dynamic registration, the dial will fail immediately and set the dial status to Chan Unavail. Remember that registration is only necessary to tell Asterisk where to send calls destined for a VoIP device. A device can send calls to Asterisk as long as it knows the address or hostname of Asterisk. Calling from a phone to Asterisk has nothing to do with registration. Registration tells Asterisk how to reach the phone. In some scenarios, it's possible for a device to successfully register to Asterisk, but network conditions prevent Asterisk from routing a call to the device even though it's still registered. Most commonly, this happens when there is a firewall between the device and Asterisk. The firewall has closed the port on which the registration dialog occurred. In this situation, you can set qualify equals yes in the Asterisk configuration for the device. This will cause Asterisk to regularly send keep alive messages to the device, which is a good way to keep a firewall port open. As long as the recognized traffic is still being carried on a firewall port, it usually won't close. Throughout this module, we've used the generic term VoIP device repeatedly. We haven't specifically said phone very often because registration doesn't necessarily have to involve a phone. It's possible for Asterisk to register to a VoIP trunking provider or to another Asterisk system. In the general section at the top of SIP.conf or EECS.conf, you can add a line in the format shown here to tell Asterisk to register to a remote server. This is a simplified example for the sake of instruction. There are several other settings you can configure in the register statement, which you can read about in the sample configuration files. First, the word register is listed, followed by equals greater than. Next is the username, then a colon, then the authentication password for the specified user. Next is the @ symbol, followed by the IP address or DNS name of the server. After a slash, the optional callback extension is listed. This is the extension in the dial plan on the local Asterisk system where the incoming call will be connected. If you don't list an extension, the S extension is used. Calls are sent to the default context unless you've configured it differently. To do this, you can replace the IP address or DNS name of the server in the register statement with the name of a peer defined later in the file. For instance, if you're connecting to siptrunk.example.com, you might have a register line that looks like this. But if you wanted to configure to the context used for incoming calls via this registration, you could instead have a register statement that looks like this, and define a mytrunk peer below that in sip.conf. This way, incoming calls will be connected to extension 1234 in the from external context instead of the default context. Registration is a valuable tool for administering VoIP networks. It reduces maintenance overhead by letting phones and other VoIP devices notify a registrar such as Asterisk of their location on the network. This way, Asterisk knows where to send inbound calls for registered devices, even when they change addresses or are moved from one network to another. Asterisk can both send and receive registration requests. Next, we'll look at latency and jitter, two characteristics of IP networks that can affect the quality of VoIP calls.